Good afternoon, everyone. I'm delighted to be here representing DANU and with Kenny and Andrew here. So when I came back to Ireland in 2015, there was nothing like this happening in Ireland. So I ended up going over to the UK, and I was very fortunate to meet up with Natasha Gidding with Region Ag in the UK, who were doing lots of courses on biological farming, regenerative farming. Natasha introduced me to a lot of farmers in the UK, so I spent a year there working on farms, visiting farms, and attending courses. So when I came back to Ireland in 2016, I really wanted to connect with like-minded people here in Ireland, and Rory McGaughran suggested I attend a biodynamic meeting, and it was there I met John McHugh and David Wallace. I really liked what John was doing on his farm, and I asked him if I could pop by for a visit. So John, I went up to the farm and had a really good visit, and I was heading back down the road thinking, right, I'm starting to make some contacts here, it's really good. And that night I was surprised to see my phone ring, and John's number pop up. It was around 9:30 at night, and I was like, okay, what's this about? And next thing, what I didn't realize during the farm visit was I was actually being vetted. David Wallace has said to John, check that Beecher file out, see what he's about. And I was like, so they were ringing me and asking if I would be interested in getting involved in DANU. So what I want to say is I want to thank Natasha for support, David and John for inviting me to be a part of DANU, and to Knots and Sean McGlowan for setting up this amazing event. So in terms of DANU, David last year gave a talk on what DANU is and what we're doing, and I'm going to give a quick recap on how is the trial set up. And basically we've got 12 farms, 6 tillage and 6 grassland. And we've got 4 trial plots on each farm. So you can see here, we've basically, the first plot is control, and we're following Teagasc Green Book guidelines and recommendations. Plot 2, we're using all artificial nitrogen and acid phosphate as buffered with a carbon source. Plot 3 is a full mineral balance, and plot 4 is full mineral balance plus biology. So David gave an in-depth talk about what we're doing, and if you want to check that out, you can go on to Knott's YouTube channel, and the talk is on that. Like all these talks are being recorded, so you can check them out. So DANU, if you know, is actually is the Celtic goddess for soil fertility. So the first thing we did was we decided to say a few prayers. So one of the key things I found from being over in the UK and reading and learning and going to different workshops was this key statement kept coming up. Observation is the key to intelligence. So we started doing a lot of observation. So we started off with mapping. You can see here, we looked at some historical maps from 1837 to 1842. And you can see there was an old house here actually on the trial plot. We then looked at more recent maps, and this is actually the trial plot from Andrew's farm. You can see back in 2000, there was actually a different crop in here, completely different. And when I was walking that trial plot, I was saying, Andrew, what's going on down here? It's completely different to the rest of the field. And we had a look at the maps, and we realized, yeah, okay, it was being treated completely different. And we realized that was going to have a big effect on our results. So that meant we went on to Google Earth, and we basically broke the trial down here. They basically didn't take any samples from here. Then we had to take into account of the boundary line and the influence of the boundary. So essentially the blue lines here is the areas we sample all the time. So we avoid the edges, and there's a stream coming down through here. So we're trying to create a uniformity within the 4 trial plots. We looked at the Irish Soil Information Systems maps, and then we actually started looking at a baseline, gathering some baseline data. We did water infiltration. We used the penetrometer to check out our soil compaction. We looked at our soil structure. We dug lots and lots and lots of holes. And then we used the VES system, so the visual evaluation of soil structure. And this guide is a really good guide to score your soil, to actually assess the soil quality. And you can see here, you can get a score from 1 to being really friable, down to 5, which is very compact. And so we gave basically a score to all our soils in each plot, individual plots. We did earthworm counts, and then as Helen talked about this morning, there's 3 different types of earthworms. So we actually broke them down into like the leaf-dwelling earthworms, the topsoil earthworms, and the deeper earthworms. And we also counted the number of juveniles as well. We've done a weed survey. We've also looked at chemical analysis with Southern Scientific. We've done our Morgan's tests, our Melic tree test, our Aquaregia. We've looked at our base saturation and our ratios. We've also looked at our biological assays, looking at the biology in the soil with Soil Biolab in the UK. And they've basically looked at the organism biomass, looking at the active and total bacteria, active and total fungi, and then the ratios of these guys. And then we've looked at our protozoas, our nematodes, and our mycorrhiza colonization. You've heard about bricks a lot over the last 2 days, and so we've been doing a lot of brick sampling as well. We also measured our soil temperature and our electric conductivity. We did a lot of in-field sap analysis throughout the growing season, so we were measuring sap pH, nitrate level, calcium, potassium, and sap conductivity. We also sent some soil samples off, or some grass samples and plant samples off to Novacrop in Holland, and they basically analyzed our pH, our electric conductivity, our potassium, calcium ratio, magnesium, sodium, ammonia, nitrates, and then we're on, like chloride, sulfur, silica, iron, copper, etc. So real deep analysis of our sap, and we monitor them a couple of times throughout the season to see how we're putting out foliar applications and seeing how they were changing or affecting and adapting our foliar applications to suit our sap analysis. We installed sensors we partnered up with the Grow Observatory project, and these sensors measured our soil moisture over the course of the last 6 months. We looked at, it's also measured our air temperature, and it looked at our sunlight intensity. So we've also taken soil carbon. We've taken soil cores from 0 to 10 centimeters, 15 to 30 centimeters, and 45 to 60 centimeters. We're measuring the labile carbon and the total carbon and subtracting those two to get our stable carbon as well. We've measured our bulk density. We've also gotten our percentage sand, silt, and clays, our PED structure, and our upward capillary potential. So, as I said at the start, observation is the key to intelligence. But I'd also like to qualify this with the fact that you need to understand what you're looking at. So what are we looking at? The essence of this project is biological farming. So what is biological farming? The clue is actually in the word. Logos equals study. Bios equals life. So biological farming is the study of life. So we're studying life. So life requires air, water, food, shelter, and sunlight. The question is, are we providing these on our farms? Are we biological farmers? And the answer at the moment is not yet. Compaction is a major issue on our farms. 7 of the 12 farms, for the water infiltration, was taking an hour plus. I was actually having to walk away, come back. Some of them it wasn't even going down. So compaction is a massive issue. Looking at the infiltration test, we can also see it showing up here in our penetrometer readings. So you can see here, the penetrometer reading, when you get, Will Armitage talked about when you get up to 300 psi yesterday, that's basically where the roots stop struggling to go. And you can see in this line here, we were reading 300 psi at about 10 centimeters. So that was where the roots were struggling to continue to grow. And you can see, once you got down into this lovely soil, the actual penetrometer was able to go right down. So we're only farming 10 centimeters. This penetrometer is 70 centimeters deep. So there's huge potential there, but we have a compaction there. We can also see this compaction in roots. You can see this root here just forking, showing that the compaction is a big issue as well. This is a very strong taproot, and that's struggling to go down. So our plants are telling us as well that we have issues with compaction. Our soil structure analysis, again, when we dug a lot of holes, you can see here, this is from Kenny's field, and you can see here, again, you got your roots coming down to about 10 centimeters, but actually it's even getting worse as you go along over here. It's probably only about 3 or 4 centimeters. So clearly you can see compaction is a real issue across a lot of the farms. And this compaction was also showing up in our biological assays. Ciliates here are high on all these 4 farms here. And you can see ciliates are a sign of anaerobic conditions. Ciliates eat anaerobic bacteria. So the more ciliates you see, the more anaerobic your soil is. And also, when you stick your nose in it, you know it's anaerobic. You smell that ammonia, so that's another good indicator. So essentially, we have 5 different tests telling us that compaction is an issue. So it's really important not to rely on just one test. You know, and for an example of that, I was up on another farm, Stuart Rogers, and was using a penetrometer. The penetrometer went down, nice and easy, down to about 30 centimeters, 1 foot, and looked like, oh, this is perfect, no problem. But then I came along, and I put the infiltration ring on, and the water just sat there. It didn't move, it just sat there and sat there and sat there. And what happened was we had surface compaction. Just the top, like 10 centimeters, was smeared in right nice and tight. And Stuart had sheep on it over the winter. So they smeared the whole surface. So if I just looked at the penetrometer, I think, oh, this soil is perfect, no problem. But when you look at the infiltration, you can see, oh, there actually is an issue. So that's why it's important to have multiple analysis to make sure that you're actually seeing a true result. So, and also it's important to understand there's potential variabilities in each test and also a lot of variabilities within your land, within each field. So, for example of this is on Kenny's farm, and we had 3 different rings, all within like a 60 centimeter center there, maybe like 40 centimeters here. This one took 1 hour and 25 minutes and 29 seconds. This one took 2 minutes and 55 seconds. This one took 56 seconds. This was bare soil. It was basically, so that was really hard and compact. This had some nice roots in it, and this one actually had earthworm castings. So it just shot right down. So it was a really interesting, so you have to understand the variabilities within the tests as well. And Will Armitage, Andy Howard yesterday talked about bricks and the variabilities and how to test it and see it and analysis. And we could see that as well in our results. This is some from field data I took at another farm, and basically it's the same plot, but you can look here at the time. It was at 10:22 on the 9th, and then at 20 past 6 a week later. But the weather is a major influence. You got light rain here, and it was nice and sunny. It's been sunny for about 3 or 4 days prior to that. The leaf stage is pretty much the same, and you can see here I recorded the air temperature, but you can look at the bricks. The bricks here is 2.5, and here the bricks is 10. So it's a massive difference, and a lot of that will be due to the weather and the time of day. If you're measuring bricks in the morning, it's definitely going to be different to the bricks in the evening, and you'd want to see it higher. The other thing here is you can see I've got no results here for air, soil, and soil EC. And that was another lesson in terms of, this is the probe we had for the EC meters, and they had a little rubber seal here that kept coming off. And so it's important to actually have backup, so that so it doesn't affect your data. We've also been just measuring, we're doing a lot of analysis, just writing down what we're seeing. So we've even been recording the color of the sap, the bubbles, when you're squeezing it out, if there are bubbles on it. The line is clear, so when you look through the refractometer, sometimes you can see this nice clear line, and that is an indication of simple sugars. And you want to see a nice fuzzy line where there's actually more complex sugars. So that would correlate with the higher bricks. And also you got blue over white. So the bricks, when you look into it, you got blue and white, but sometimes you get a blue and cream when you get higher in your bricks. So we've just been recording that, and here you can see we have our sap pH. We say that sap pH should be 6.4. You can see which is actually fairly close here. It's nearly bang on the money. And with a bricks of 2.5, and then you see when bricks is 10, it's 6.0. So we've looked at all these sap analysis, and to be honest, they've been more confusing than anything else. But what we're doing is trying to look. You're not looking at one test in isolation. You're looking for trends and patterns across all the various tests and across the farm. So it's all for looking for trends and patterns. And so that's what you're trying to do. All these tests are looking for patterns and then trying to get you to a clearer picture of what's going on. So this brings us to the question: what is the key to biological farming? And the key for us is farmers retuning their senses. So Colm wasn't actually saying a few prayers. He was actually chasing a chicory root It was gone down about 90 centimetres, like 3 feet. He was chasing it down. And Colm, like the best tool to tune into your land is the shovel. You're just digging a hole, you're looking at your structure, you're out there. Colm was looking at his bricks, looking at his sap. He's done like a weed survey of over 100 plants, or we shouldn't call it weeds, they're really good indicators of what's going on. And so he's really tuning into his land, trying to understand what's happening on his farm. So you can go to all the conferences and read all the books, but unless you start tuning into your land, biological farming is not going to work for you. You know, you are the key to biological farming to be successful. So I'm going to hand you over down to Kenny, and Kenny's going to go through his experience with DANU over the last year as well.
Hello everyone, my name is Kenny Roberts, and I am here to tell you about my first year DANU experience. So I'll just give you a brief background of myself. I'm a beef and dairy farmer from near Rothangan in County Kildare, not too far from here. I milk a herd of 120 cows, nearly all purebred Montbelliard, with a few crossbreds thrown in, and we finish all calves on the farm as beef. So I suppose since I came home from college to farm with my uncle, I would have followed the Teagasc Green Book method of farming, which is the MPK system. So that's going back really about 20 years now. So soil types would vary on the farm as they do on most farms in Ireland. I mean, you can walk 20, 50 yards up the field and it's different soil. But so just for the DANU trials, the clay it's a clay, loam, and peat over a marl, which is actually quite different to a lot of the other DANU members' soils. And all farm would be down to grass or a grass clover mix. Well, so why did I join DANU? Maybe some of you are asking. Well, I hadn't heard much about biological farming until 3 or 4 years ago, to be honest. My first introduction came after a friend of mine recommended attending a soils course run by David Wallace, who was my old Teagasc advisor. I found the course very interesting, even if it did contradict a lot of what had been taught about farming. I suppose it opened my mind about the method of farming that I've been practicing. Things that I'd taken for normal, like loose dungs, high milk urea, spreading nitrogen too close to grazing, average number of lactations in the herd, use of wormers, root depth over perennial ryegrass swards, as Dave has shown pictures earlier. I started to question all these. Also having to buy a lot of minerals to feed the cows, like why are they not in the grass or in the silage? So a year or two later, I was asked to join DANU, and I jumped at the chance. So started DANU, there's 12 farmers. One of our facilitators has described us as 12 apostles. Sometimes I think we'd like the dirty dozen. But anyway, so I suppose we had to pick 4 trial plots. Hold on 1 second there now. I'm missing my gun. Sorry, I'm after forgetting about all my slides, so I'll just have to. There's a picture of my farm. Yeah, I think I'm on the right one now. Sorry. Where was I? Yeah. So yeah, we picked the 4 trial plots, and Dave came out. He came out and he did a field report, and the results are here in the slide. So I'll just. Where's sorry, 1 second. So just know if you might be able to see that there. Just some of the results I found there. So the max root depth, or the average root depth here was 6.88 centimeters, if you see it there over the 4 trial plots, and the topsoil depth was 17.5 centimetres. So in reality, I'm only farming 40% of my topsoil. And then here, the VES, which is the visual evaluation of soil structure, is 3.43. And obviously, as Dave mentioned earlier, it should be closer to 1, so it's not a great soil structure. So down to the worm counts. And there's a picture of the measly worms that I had on my farm. So I had, on average, 4.25 worms, where they should be up near, this was now per hole that they've dug, so the spade across. So there should be 25 really worms in that. So the day I went out, I was kind of got a big shock there, I was nearly going to go. It's like, when you're a kid and you're trying to get some worms, I was nearly going to go in and get some washing up liquid there in the bucket of water and throw it in to see was there any more, but there was no more there. So, then this is just the results of mine here. The PSI at 200 there is 6.75, and at 300 is 9.5. So it's not that deep, It's like roots are going to get it pretty hard to penetrate down. Sure. When I looked into the holes that Dave had dug, and he dug a lot of holes in my farm, in all fairness. You could see all the compaction. So, and also there was a clear iron pan between the topsoil and the subsoil, which would obviously be a sign of compaction. So there's some biological assays. So we did biological assays, and from the biological assays, the results confirmed what we had saw with our own eyes in a way. So the flagellates here were low, the amoeba was low, and the ciliates were high, which is a classic sign of anaerobic conditions. So it just all started to tie in together what we were seeing, all these results that came back. It's just the one thing I was encouraged to find down here. At least I had some sort of a population of mycorrhizal fungi, which was below optimum. But I suppose in time, as we go on with this project, if the environment in the soil is improved, there will be an increase in these, which would be important for carbon sequestration, which all due to glomalin production and deposition, which all seems carbon sequestration seems to be the buzzwords these days. So in summary, I don't have a balanced soil biology at this point in time, but because hopefully in time we'll get there. So just on Dave's put these up before here now, they weren't of my farm, but there's just the soil tests. They were taken and they were sent to Southern Scientific. They were taken, I suppose, on a premise that if you don't measure trace elements in the soil, you won't know if you have a problem. On my tests, we found that my soil has a high, just move on to the next slide here, you might be able to see it a bit better. Up here, where is it? Next one. It has a high exchange capacity, which means that the soil actually has a high capacity to store nutrients. So some of the figures that stood out were just down here. It was my high calcium, and that resulted in being quite a high pH due to excess calcium. But the one thing I learned is that the calcium might not be bioavailable in the plant, because David came out one day and we met on the farm, and he told me to bring a cup and some vinegar So we did a fizz test by adding vinegar to the bit of soil in the cup, and it fizzed up, which this meant that the calcium is in the carbonate form, and so it's not bioavailable to the plant. Also here, we're pretty low on magnesium. Even though I'll just go back one slide there, in the Morgans here, the magnesium is quite high, but it's low here, yeah. So I'm actually still trying to get my head around what some of this stuff means. Also here, the iron was quite high, and I'll be referring to this later. There are ratios here on the results between different nutrients, and these are quite important ratios. And as I said before, it's going to take me a bit of a while to understand the effects, what some elements have on other elements. So maybe I should have listened a bit more in chemistry class in school. There you go. So we have 4 trial plots. Plot 1 is just the Chagas Green Book. I think Dave's put this up before, but I'll just go into explain a bit more on it. Plot 2 is the Chagas Green Book plus a carbon source. Now I've used molasses at 20 litres a hectare for this. And plot 3 is trace element balancing, and plot 4 is trace element balancing plus soil biology treatments. So there are 4 plots. Excuse me. So during the year, we've gone on plot 3 and plot 4 with 6 units of nitrogen a couple of days after each grazing, along with a trace element mix as a foliar application. So that was plot 3, and plot 4 got exactly the same, only it got N, P, and K fixing bacteria. That was the only extra thing that plot 4 got. So I suppose I'll just show you a quick picture here. On the right here, that's plot 1, and here's plot 3. So during the year, I'd say if you took plot 1 at 100%, I thought the plot 2 grew maybe 10% more, and plot 3 and 4 grew 10 to 15% less, which wasn't bad, I suppose, considering it only got 6 units of nitrogen plus a trace element mix. So I was pretty happy with that for the first year. So during the year, I would have taken some grass clippings and sent them to Novocrop in Holland for sap analysis, and the results came back were pretty interesting. On plot 3 and plot 4, most of the trace elements in time after applications began to rise. Apart from the iron was one actually that didn't rise, and the iron was actually high in the soil, but it was pretty low in the sap analysis. So I added extra iron sulfate to one of the mixes and took another sap analysis, but still didn't move in the right direction. So the next time, after a bit of discussion with some of the group facilitators, we decided to add in fulvic acid with the iron sulfate. So basically, what was happening, like the iron in the soil is in an oxidized state, so it's not really available to the plant. And look, it all goes back to compaction again, being in that state. So so the fulvic acid. It helped it be in the reduced form, and this. So basically, in the next, sorry, I'll just put the next slide on there now. So if we can see here, where is it? Iron here. So I don't have the first analysis it took, but the iron was way back somewhere here, even though iron is quite high in the ground. So that was just after one application of iron sulfate plus fulvic acid. So I suppose you have to really know what it's no point just going out and throwing some iron sulfate. You really need to know what you need to be putting on. So, and that even goes back to the iron pan was visible in the soil. And as we know, like all these trace elements are important for effective photosynthesis. I suppose it's easy to get hung up on the figures. They're there to help us establish an overall feel of what's going on, but they can fluctuate, so I suppose you need to be careful. The trace elements will be applied on my trial plots until soil biology is able to provide these trace elements for the plant. Another thing, I suppose, as Dave alluded to earlier, is to observe and see what you are looking at. I'll just give one example there. I walked out in a paddock one day to look at a cow, and when I was walking through the paddock, it was their first grazing, and I'd noticed that they'd pushed all the grass down around the dandelion, and they just cleaned it to the butt. So after doing a bit of research, I figured out that cow was looking for calcium. So these are the little things that I would never even noticed before. Finally, in relation to soil biology, I suppose it's an ongoing learning process for me, and hopefully by the end of the DANU project, I will have learned a lot about soil biology. And if anyone was thinking of starting out on their own journey, I would be in a position to maybe help them out, or at least to point them in the right direction. Okay. Thank you.
My name's Andrew Bergin. I'm going to take you on a quick run through my farming system, my journey to biological farming, and the role that DANU plays in it. Yesterday, Andy Howard remarked that farmer-to-farmer interaction is the best way to learn, and I think DANU is a great example of that. That's why I think I'm pretty lucky to be a part of it. I run an arable, not tillage, John, no longer, farm, about 20 minutes away from here in Earthhigh. The soil is pretty uniformly light, sandy loam. It's easily worked, but can be prone to drought in what is, believe it or not, a dry part of the country. pHs are high, and nutrition can be a bit tricky. Yields are moderate, so I tend to focus on premium crops to try and keep income up. The biggest single crop is malt and barley. It's a traditional crop in the area, and some of the ground I farm is closer to the maltings than it is to my own yard. Also grow oats. They grow well here, and again, we're trying to produce either seed or gluten-free wherever rotations allow, and that's usually winter sown. Grow peas for canning for human consumption. I love them as a break crop. The picture on the right, though, shows you why the harvest can hurt your affection for them sometimes. Winter wheat is also grown, but only after a break, and again, usually for seed. In the picture there, I don't know how clear it is, there's actually a couple of ladybird larvae on one of the middle heads there. We haven't used an insecticide for a good few years, and so I'm very happy to see these guys appearing. And on the question of insecticides, probably the only place that I think we've maybe really suffered from that is in a crop of winter barley we had last year, which had a fair bit of BYDV in it, barley yellow dwarf virus. On the other hand, an awful lot of crops that got 2 and 3 insecticides had the same issue, so I don't know that we really suffered simply because of that. In early September last, I sowed my first crop of oilseed rape. I'm hoping this will be another useful break crop. It's one I've always avoided because I was afraid to bring in slugs, but I'll come back to the reasons why that's not an issue anymore. I try to sow a cover crop ahead of all spring crops, and where possible ahead of a winter crop as well. Now, that's not always possible in autumn like this. We haven't even got it in ahead of all the spring crops. This slide actually shows the picture on the left is a crop from a picture taken in late October last year on a crop that was sown in mid-August. The picture on the right is the same field with the same sowing date, picture taken much the same date this year. And the difference between the two is worth bearing in mind when we talk about trials later on. Traditionally, this land didn't need more than a quick run of a springtime to make a seed bed when we were back ploughing, and we would always roll after sowing to tighten it. Over time, probably once we maybe got into the 2000s, we found that we actually needed to roll ahead of the springtime to tighten the ploughing again. And at this stage, I see a lot of my neighbours who are still ploughing using very heavy presses, which you wouldn't normally associate with this light land, in order to reconsolidate that ground. And I mean, I I didn't know it at the time, but I certainly see that now as a sign of depleted soil biology. In April 2013, purely out of curiosity, we got a field of spring barley strip drilled. It was a really difficult spring, and this crop took off with much better vigor than any of the conventionally sown stuff that we had. I was impressed with the establishment, I was impressed with the crop, and I was impressed with the low labor and the low cost, and particularly the amount of work that one man could do with a machine like that. Out of curiosity, the autumn of that year, we also sowed the first cover crop, or a strip of it, into a field, and was amazed at how much more friable the soil in that strip was the following spring when we went to sow it. So we now sow cover crops, as I say, pretty much wherever we can. Slugs arrived at the same time as both the arrival of the cover crops and the reduced tillage. Now, it's hard to know when you change two things at the same time which one has the effect. I'm inclined to think the cover crops and maybe the brassicas in them. But we did move everything to strip tillage over the following couple of years, and we started placing fertilizer with the seed there because we weren't happy, again, from trying some trials with and without, we weren't happy that the stuff on top of the ground was getting to the seed when we wanted it to. About 4 years ago, I bought an old horse tine drill, which disturbs less soil, takes less power to pull, and we fitted a liquid fertilizer system to that. That can also put in trace elements, biostimulants, or whatever else we're in the mood for. There's not much cultivation. We sometimes use a straw harrow here on the left to spread chopped straw if it's there, also to disturb slug eggs. Occasionally we need to till the ground ahead of the drill, usually if there's too much residue from cover crops or chopped straw, but it's also a useful way to disturb slug eggs. I think we were getting a bit puritanical about no-till at the start, and we've backed off from that really. It's a case of as little as possible and as much as necessary. I find it pretty easy to see the system being better for the soil. On the left here we have a picture of a barley plant at about the 3-4 leaf stage this year, which has much better roots than I'm used to seeing, with not fabulous adhesion to the roots like Christine was showing, but again, much better than I'm used to seeing. The picture on the right is actually from stubble of wheat this year. Again, it's a bit blurry, but it was just a massive worm cast, which something I'm certainly not used to seeing. So that was all good progress. Now, joining base in Ireland started to tie some of these pieces together for me, and everything moved up a couple of gears. I began to understand what biological farming was supposed to be about. I had reduced my establishment costs. Some of that money was being put into cover crops, but average yields were steady at where they had been. So I was doing less work and getting much the same return for it, which was great. Slugs were there, but they weren't really a major problem. Sterile brome came in. We kind of getting on top of that now with careful rotations, but yeah, grass weeds could be a problem in this. But despite all the conferences and base meetings were great, and the base chat was great, and books I was reading were great, I couldn't really work out how to take this to the next level. Dave had done a biological assay for me which showed lashings of bacteria and not a whole lot else, and absolutely no fungi. And we had done Albrecht tests, and we'd done total tests, and we'd done tissue analysis, and I was a bit like a pig looking into an airplane. I was excited but clueless. And so when the proposal for DANU came, I grabbed it with two hands. I could see that piecemeal changes weren't going to deliver the improvements in the system. It needed to be a system, because I could just, and there's plenty of guys plenty of well-meaning people are going to give you advice, and there's plenty of people who are going to make some money out of giving you advice too if you want to do it. So I was after like I say, a whole improvement in the system. So, DANU looked like a privilege and a challenge, and that's exactly what it's proved to be. Its idea is to look at how a farm transitions from conventional to biological farming. So even formal trials of individual elements, I don't think I don't know how much they're going to add up to in isolation. Like if you think about the cover crops that we saw there, same field, 2 different years, 2 completely different results. Now, if that was part of a trial that wasn't taking account of the weather, well, how much would it mean? A biological system is, it's a living interaction between the physical, the chemical, and the biological. And that's the interaction that DANU is looking at. By testing 4 different approaches on 12 farms over 5 years, it's going to measure the ongoing and the cumulative effects of each approach. And it's also a dynamic trial, so we really don't have a clue what we're going to be doing by year 5. It will respond to the observations that we make throughout the trial. And this will be data from Irish conditions, so there'll be no more of this, that's grand wherever you are, but it won't work here. This is going to be what works here. And this is why I say it's a privilege for me to be involved. While there's a nice little bit of work in DANU, I'm getting results actually on my own ground, which is grand. I don't think that a study like this would fit in very well with a conventional research institution. It would be pretty expensive to do it on the scale that you would need to get the results. And I don't know that it could be as adaptive as we can be, because somebody else referred earlier to farmer trials as dirty trials, which that's grand with me. They probably are, but I think they can be very, very useful for all of that. I don't think any single farmer would have the skills or the finance to do it themselves. But when you bring together 12 farmers with the same appetite for progress and you give them the kind of expert guidance that we have, I think you really can go places. And it's about farmers. I was going to say taking back control, but it's about farmers having power and responsibility, and it really is, the two go hand in hand together, because if we make up our own minds what we're doing, we can't blame anyone else. This is our, this is our show. But it's not setting out to prove any particular hypothesis, and I don't expect it's going to work out a foolproof formula for transition into biological farming. I do expect that it'll help farmers who want to make this change to make less mistakes and enjoy more success than they would otherwise. But there won't be any magic bullets, because biological farming is not prescriptive and it's not streamlined. And I don't think that most of the people involved in it really want it to be. By building a body of knowledge and experience, we hope that we can help more people to practice it successfully in their own individual ways. Thank you.